Hello, this is the AQA GCSE Mathematics Foundation Paper 2. These were meant to be the practice questions for November 2021. So let's have a look at it. You're allowed to use a calculator and you have an hour and a half to do it. First question. Circle the factor of 36. That means that one of these numbers, you can divide 36 by it and it will give you a whole number. If you know your times table, you'll know it's 18. If you don't know your times table, what could you do? Well, you're allowed a calculator, so you could say 36 divided by 72 and you'll see that it comes out as a decimal. You could 36 divided by 18 and you see it comes out as a whole number. So that worked. You could do the same with the other numbers, but there's no point. We have found our factor. 2 lots of 18 is 36. Question number 2. Why is 5 more than x? Circle the correct equation. Well, here it's understanding that if you're talking about more, what you're doing is you're actually adding an extra 5 onto it. So we're looking for something that says adding, and you can spot it here. Y is 5 more than x. Question 3. Circle the value of 0.6 as a fraction. Once again, you have your calculator available, so make sure you know how to use it. And in this case, enter your various fractions you have, turn them into your decimals, and you can see the first one we did, 3 over 5 or 3/5 came out as 0.6, which is indeed what we were looking for. But you could do it for the others, and you'll see that if you do that, it doesn't give you the answer. Okay, so here we are. So far we've been quite lucky. We haven't had to do all the answers to check which one it is. We're on to question 4. And question 4 says here's a rectangle. The side of the rectangle is S and the side along here is W. Circle the expression for the area. And that is remembering that the area of any rectangle is the base of the rectangle multiplied by the height. Now that's what I call them, but you could call it side times the other side. It's up to you. In this case, we would have S times W, S times W, or W times S, because in multiplication that works out the same. So looking for something that has an S times a W or W times an S. And as you go along and check, there's a plus there, so that's not going to work, plus there, and so it's going to be one of these because there's a multiplication. Notice we don't have any 2 here, so the answer is going to be this one. That tells us that it's S times W. It's the way algebra is, you don't write the times symbol in there. Question 5. Work out the value of a squared plus 3a. And they tell us that a is worth 4. So this is a case of substituting. So wherever a is, so that we're going to substitute in the 4. So we have here 4 squared plus 3 fourths, and remember in algebra that's a multiplication, so that's the calculation we need to do. 4 squared, if you have your calculator, because you don't know your times table, 4 squared is 16 and 3 times 4 is 12. Remember the order of operation, you do multiplication and powers before you do addition. And the last bit is 16 plus 12 to get an answer of 28. You could have used the calculator for the whole calculation, especially if you have one of the scientific ones. Let me just write the answer down here. 28. Beautiful, 2 marks. We're on to question number 6. Question number 6 tells us that there are 16 people and they were asked the name of their favourite cake, and here's some cakes. Here's the frequency telling us how many. 7 people like sponge cake, etc. One of the people was picked at random. Work out the probability that their favourite cake was carrot or walnut. So where is the carrot and walnut? Here we are. So if we add those together, 5 plus 1 is 6. So there's a 6 out of a total. And how many people were there? Well, if we add these together we get 16, but up here it also says 16. So 6 out of 16 is the probability that randomly somebody would choose carrot and walnut as their favourite cake. On the grid, draw a bar chart to represent these results. They've been very nice. We had 4 cakes and we can easily fit in 4 bars. What's the highest number we have to accommodate? 7. And if we look here, we have 1, 2, 3, 4, 5, 6, 7. So they've been very, very nice. They've actually given us exactly the right number of boxes. Sometimes they won't be that nice, and in that case you'll have to perhaps have every box having a value of 2, but in this case every box can be 1. Now you don't have tons of time to do this because it's only 3 marks, so let's put some information on. So here we have at the bottom 0, and we have 1, 2, 3, 4, 5, 6, and right at the top 7. And what is that? That's the frequency, so let's label it frequency. Okay, and along here we're going to have our favourite cakes. So the first one we're going to do is sponge cake, and sponge cake goes all the way up to 7. Remember, your bars have to be equal width and the gaps have to be equal spacing. So I'm going to make them all worth 1, and that there is going to be my sponge. And let me just quickly colour it in. And then the next one is going to be fruit cake. Less people like fruit cake, only 3 people like fruit cake. So make it 3 bars high. Colour it in. And this one is called fruit cake. The next one is carrot cake, even less people liked. Only 1 person liked carrot. Now it's a good idea to use a pencil if you think you might make a mistake, but this is quite simple today, so we can do it straight away with a pen. Carrot, and the final one is walnut, which we've got 5 boxes. And that was walnut. Okay, 3 marks, so worthwhile making sure that everything's labelled, equal gaps between them, equal spacing and bar widths, and everything's labelled. Brilliant, 3 marks. That's quite nice. Now we're on to some calculations. Question 7 tells us that 8 pies costs £11.92. Work out the cost of 13 pies. Now there's different ways of doing this question. I'm going to show you both of them, well, 2 of them, there's many more. So the first one is I'm going to say that if we look at the number of pies and the cost, number of pies 8, and that cost £11.92. And what do we want to do? We want to find out how much it is for 13 pies, and we're looking for the cost. Okay, now what I'm going to do is I'm going to go and find, first of all, how much does it cost for 1 pie. To do that, what you have to realise is that if 8 things cost that, to find the price of 1, you're just going to have to divide. Okay, if I divide that by 8, I'll get 1, and if I do it on the left hand side, I will repeat it on the right hand side. So now we have 11.92 divided by 8 gives an answer of £1.49. But that's not what we wanted. We wanted to know how much it was for 13. So if one pie costs £1.49, we want to work out 13 of them, so we're timesing it by 13, and that means that we'll do that also on this side. So our answer times 13 tells us that it costs £19.37, which kind of makes sense because it's going to be more than the cost of 8 pies. And we can write the answer down here, £19.37. Some of you might use a different method. You lay it out in the same way. Pies 8 cost £11.92, and we want to find out how much it is for 13 pies. That's what we're looking for, and to do that we can multiply these together and divide by that, and if you did that you'd get exactly the same answer, 13 times 11.92. It's just a different way of showing it, and then divide by 8, and you'll notice we get exactly the same answer. There we are. Moving on to question 8, and question 8 is asking us, or telling us, that here is a cuboid, and they give us the various dimensions, the 3 dimensions of the cuboid, and it's asking to work out the volume, and that is where you need to remember that volume is basically one of the lengths times the other length times the other length. Now what you might call them is width, height and breadth, or whatever you want to call those, but I'm just calling them length 1, length 2, length 3. We substitute the values in there. First one was 7, next one is 9, and the following one is 6. Now of course it doesn't matter the order. Multiplication, you could have done 6 first or 9 first, it will come out the same. 7 times 9 times 6 gives an answer of 378. 378. They've already put the centimetres cubed, so I don't need to write that down. So let's move on. What does question 9 look like? Question 9 is presenting us, and it says work out two numbers that are multiples of 7 and have a difference of 28. So they're testing that they know what you know what multiples mean and that you know what a difference is. So we're going to start with the multiples of 7, and multiples of 7: 1 times 7, 2 times 7, 3 times 7, and obviously you can use the calculator for this. 4 times 7, 5 times 7, 6 times 7, etc. Okay, so we're doing the multiple part first. And now we want to find the difference. It means if I take two of these numbers, we want the difference if we subtract to be 28. Okay, so let's choose two numbers. If I do 28 take away 28 will give me 0, and there's no 0 here. And there's no point starting with something smaller, because if it's smaller it's going to give us a negative number, and we want the difference to be 28, and I don't want to complicate my life. Okay, so let's start with 35 then. Let's test it out. So if I do 35 take away 28, because that's going to be the difference, and see if it works. 35 take away 28, and it does give me a multiple of 7, so both of those numbers are multiples of 7. So you could have had here 35 and 7, or write it 7 and 35. Okay, but you could have chosen something else. Let's test it out. You could have had 42 take away 28, and that would have also worked. So you could have had 42 take away 28, and that would have given you an answer of 14, and so you could have had 42 and 14 here, and there's many more. Okay, that's just an example of something that worked. You might find something else. Question 10 is a very similar question to question 7 that we did. Okay, it just looks different because of the words, but the actual method is the same. So they give us something here, and they're basically saying kilometers and miles. 8 kilometers is the same as 5 miles, and they're asking us to work out how much is 20 kilometers in miles. Notice once I write it like that, it looks very similar to the previous question we had. So you could multiply these together and divide by 8, or taking the logical approach, we could find out how much 1 kilometer is, and to do that we need to divide by 8. It's the same here, we're going to divide by 8, and then afterwards 1 to turn it into 20 means we need to multiply it by 20, so this side to keep it balanced will also be times by 20. Then you can get your calculator, and you can say 5 divided by 8 times by 20 gives an answer of 12.5. So 12.5 miles. And notice they've written miles here, so I don't need to write it down. Excellent. Question 11 looks to be a long question. It's 3 marks and it's a full page, but if you read it carefully it's not too bad, because it says Anita spends these amount in 3 shops, shops A, B and C, and she uses coins that are 50p, 20p, 10p and 5p. In each shop she pays the exact amount, so she doesn't get any change. Use the smallest possible number of coins. In other words, we don't want to pay everything with pennies and have to count out lots of coins to do that. Work out the total number of each coin she uses. The way to do this is try to see the biggest numbers, use the biggest value and find, and then go down. I'll show you. So if we look at shop A, we want to make 75 pence. Now if we break that down, I'm going to break it down into 50p's. How many 50p's? 1. If I take 50p from there, I'm left with 25, so I would then need a 20 and I need a 5. Notice in this way I only need 3 coins. If I use 5p's I'd need 15 coins, which is quite a lot, and they want the smallest possible number. We'll now break it down for B, and B is 45p. I can't use a 50p coin because that's they'd give me change, and they say she always pays the exact amount. So the next biggest coin I could use is a 20p plus another 20p, that'd be 40, plus another 5p, and that'd be 45. And then we come to C. Now C is presented to us in pounds, which is the same as 135 pence. So here I'm going to have 135 pence. And to do that, we're going to have a 50p plus another 50p, because that would give us the pound or the 100 pence that we're working for. Then we'd have a 20 pence, a 10p, and nearly running out of space, I'm going to write it down here, 5p. Make sure you never go out of there. So 100, 120, 130, 135. So now we have to know how many coins. So let's count all our 50p's. There's a 50p there, 50p there, 50p there. So how many 50p's? 3 50p's. Okay. Now we're going to use 20p's. So here's one 20p, 2, 3, 4, 4 20p's, or 20 pence. There's only one 10 pence, and then what else do we have? Our 5 pence. One there, one there, and one there. So we have 1, 2, 3. So in total, 3 50p's, 4 20p's, 1 10p, and 3 5p coins. Question 12 spans 2 pages, and it's all to do with a frequency tree. They present some information and we're going to have to complete the tree. What we have is 42 games in a sports team that has played, and they tell us that half of the games were home and half were away. Now half is quite nice because half is basically written like this, isn't it? Yeah. So we're going to do half of 42. Half of 42, or 42 divided by half of 42 is 21. Okay, so 21 were home and 21 were away. Right, so we've done that bit. Now we need to look at the next bit, and it says of the home games, so of these 21 here, a third of them were losses. So we need to work out a third of 21. And when you do a third of 21, let's show you, there we are. Oh, there's a bit of reflection. There we are. A third of 21 will end up with 7 coming out. So 7 were losses. So we had 21 things, 10 here, 7 there, and the remaining, what's left over, will be there. So we can say we had 21, take away 7, take away 10, and we're left with 4. So now we're going to do the away games, and it says here of the away games 1/7 were wins. So 1/7 of all of them were wins. Okay, I should have written that up there also. So 1/7, so let's see, 1/7 of 21 comes out to 3. So those were the wins. So I come down here and I'm going to put here the wins. Like before, 21 is what we had. Take away 3, take away 12 means we're left with 6 that were draws. So we completed that table. They're testing really that you understand how to work out fractions of an amount, and it's 4 marks. So that's good. So we've done all those bits there. So that was part A. Then it says on part B, the team gets 3 points for a win, 1 point for a draw, and 0 points for a loss. Work out total number of points the team got. So in that case, we need to work out how many of everything. So we look at the wins. How many wins did they get? So they had 10 wins here, and they had 3 wins there. So in total, they had 13 wins. And each of those wins is worth 3 points. So 13 times 3 will give us 39. We're going to do the same for the draws. And we have to find out how many draws we have. 4 here and 6 there. 4 plus 6 is 10. So we have 10 draws times, and each of them is worth 1. So 10 times 1 is 10. And there's no point calculating losses because they get no points for those. So in total, how many more points would they have? They'd have 39 for the wins and 10 for the draws. So they have 39 plus another 10, which would be 49. We can write that down here. 49 points is what they'd get. Okay. Question 13, completely different. Now we're onto algebra, and it says factorize fully. Notice the key word there is fully. If you do it only partially, you'll only get one of those 2 marks. So we want a factor that's both in this term here and in that term there. If you know your times tables, you'll notice that 4 times 1 is 4 and 4 times 3 is 12. So we can take outside the bracket of 4. 4 times x is 4x. 12 divided by 4 is 3. So 4 times x is 4x and 4 times 3 is 12. So when we factorize that fully, we'll get 4 open brackets x plus 3. Now if you had taken out a 2, for example, you get only 1 mark because you've done part of the job. Question 14, and question 14 says some sweets are yellow and orange in the ratio yellow-orange. So the first number is yellow, second number is orange. What fraction of sweets are yellow? So in that case, you'll notice that 2 of them are yellow, so we're looking for 2 in the numerator, so that's no good. That's no good, so it's between these ones. Out of all of them, and all of them is 7 plus 2. 7 plus 2 is 9, so it's going to be that one there. Okay, so 2 out of the 9 are yellow. Question 15 presents a cuboid as shown in this shape here. It's only 1 mark, and it says which of these statements is correct, and they're checking that you know what an edge is, a face, a plane, and a vertex. Now an edge is basically one of these lines here, and if you counted them, there are more than 4, because basically you can see already that there's more than 4 here, but there's also one at the back that you 3 at the back you can't see, so that's wrong, no good. Faces, well, face, this is a face at the front, face at the top, face at the side. If you count them, you have 1 on top, 1 on the bottom, 2, 1 on the side and 1 on the other side, 2, 1 on the front, 1 on the back, 2. So we have 2 plus 2 plus 2, 2 plus 2 is 4, plus 2 is 6. So that's looking quite good. Now planes is another word for face, and if that's correct, then that one can't be. And vertices are the corners, and if you look at corners, we have 1, 2, 3, 4, 5, 6, 7, 8 corners, and so that one's wrong. So the only one that's correct is 6 faces. You're then on to question 16, and question 16, it tells us that AB is parallel to CD. Sometimes for these it's easier if you turn them around to the thing, if you're more familiar with them that way around. They also tell us that F to G is a straight line. Work out the size of X. Well, this is where you should know your various types of angles on parallel lines, but what you'll notice, or you should notice, is that that angle there, 62, is the same as the angle there, that's 62. Okay? So those are called corresponding, and because of that we know that that one's 62. Now that is a straight line, and if that's a straight line, we know that these 3 angles shall all add up to 180. So what we could do is we could say 180, take away the 62 that we know, take away the 35. Now you might first add them together and then take away, but you'll get the same answer as I do. So we're going to have 180, subtract 62, subtract 35, gives an answer. Oh, made a mistake, notice. That can't be right. And there you are, spotted the mistake in time. Excellent. 83. So in this case, X is equal to 83 degrees. And they've actually already put the degrees there, so I don't have to put a little degree sign. Okay, so it's actually quite a nice question for 3 marks if you know or can picture the various angles there. Question 17 looks like a ratio question, as they tell us, and also from here. Clara and Justine have some money in the ratio. Clara has 1 part and Justine has 2 parts. Clara has £4.20. They pay £6.50 for some food that they share. Clara uses a third of her money. Justine pays the rest. How much money does Justine have left? Okay, so for 4 marks, so we're going to have to break this down a little bit. So first step is to remember that Clara has 1 part. Okay, so if you like to think of it this way, 1 to 2, but some people don't like to picture it like that. Basically, Clara will have 1 and Justine will have 2 parts to it. okay, each of the same value. So they tell us that Clara here has £4.20. Okay, now if each of these boxes has the same value, because basically that's what they're telling us, Clara gets 1, Justin gets 2 of them, so we can see that basically there'll be 2 of them in here. Or the other way to think about it is 1 times £4.20 gives you this answer, 2 times £4.20 will give you that answer there. So if you add those together, you'll end up with £8.40. So that's what Justin has. Okay. Now, they tell us that the total money was £6.50 and Clara uses a third of her money. So now we're going to work out a third of the money that Clara has, and Clara has £4.20. So if you put that into your calculator, you'll get 1/3 of £4.20. Oops, 1/3 of £4.20, and it comes out to £1.40. So that's how much Clara spends, and Justin pays the rest. So the amount of money was £6.50. Take away what Clara pays, so we had £6.50, take away £1.40, which is what Clara pays, and so the remaining is £5.10, and that it was Justine pays. So Justine had £8.40 and she pays £5.10, and so that will tell us how much she has left. So we have £8.40, take away £5.10, and so she is left with £3.30. So that's how much money she has left. Okay, so the key thing is to understand that because Justine had double what Clara had, we could work out how much money Justine had, which allowed us then to say, well, how much she has here before we can take away what's left over to pay. They told us a third of it, of Clara's money, was used to pay, so we can work out a third, take it away from the £6.50. The remaining is what Justine pays, and we get our £3.30 out. 4 marks for that question, so it's worthwhile spending a bit of time to understand it. You're on to question 18, and this is a standard solving question. They tell us that we have 5x, take away 2 is the same as 11. And when they solve, they're basically asking what is the value of x that works there. The best way to do that is to keep the equation balanced and to slowly get the x on its own. So here we have a -2, so the opposite of that is to add 2. So we're going to add 2 to both sides. And if we add 2 to both sides, 2 take away 2 disappears, and we're left with a 5x on this side. And 11 plus 2 is 13. What's the next stage? Well, here it's a multiply by 5, so the opposite would be divide by 5. And if you divide by 5 on the left, you divide by 5 on the right. When we do that, 5 divided by 5 gives us 1x, which is what we wanted, and we were left with 13 over 5. So you could just write 13 over 5 here, or if you prefer a decimal, you can do 13 over 5 and turn it into a decimal, and it comes out there to 2.6, or 2.6 if you prefer a decimal. Okay. They haven't said give your answer as decimal, so either of those would be fine. Now we're on to question 19, and it says work out which of these fractions is closer to the value of 1. So what we're going to first do is put those into the calculator. 7 out of 16 gives 0.4375. 0.4375. And if we do 39 out of 25, we get an answer of 1.56. Now, sometimes it's easy at this point to see how close they are, but from these numbers it isn't. So what I'm going to do is I'm going to subtract them from 1. Okay, so in this case I'm going to say 1 minus 0.4375 and see what answer comes out. And in this case I'm going to do 1.56 minus 1. Now the only reason I did it that way around is to get a positive number, but it doesn't really matter because I'm just wanting to find how far away they are. So if it's negative, it would still be telling me a distance. It would just be negative, but I don't really like working with negatives. So 1 take away 0.4375 comes out with an answer of 0.5625, 0.5625, and here, well, you can see what's going to happen. If you do that 1.56 take away 1, it's going to 0.56. For comparative purposes, I'm going to have it with 4 decimal places. 4 decimal places here, 4 decimal places there, and then I can compare. It says which is closest. Well, clearly this is a bigger number, so that's farther away. This one is a smaller number, so it's closer. So the one that's closer is 39 out of 25. Okay. If it said which was further away, then it would have been the other one. Okay, we're on to question 20A, and 20A has a grid with north marked on it. Point B is 600 meters southwest of point A. Mark on B on the centimeter grid, so telling us that each of these is a centimeter, and they say use a scale where 1 centimeter is 200 meters. So if you think about it, to make 600 meters, you're going to need 200, another 200, another 200. So we're going to need 3 lots of 200, because 200, 400, 600 to make 600. So in other words, 3 lots of centimeters. So you might want to get a ruler. Now, what have they said that's key, and you mustn't forget, is southwest. Where's southwest? Well, we know that south is downwards. We know that west is in that direction, so southwest is exactly 45 degrees. So going from A, we want to go exactly 45 degrees and 3 centimeters. So to do that, I'm going to basically go through each of these points here using a ruler. So I'm going to mark it there. I'm going to make it go through each of those diagonals. And I'm going to go basically 1 centimeter, 2 centimeters, 3 centimeters. Okay, so you can see 1 centimeter, 2 centimeters, 3 centimeters. So that's where it's going to be. Okay, and that is where B is. Now, they've done that intentionally because people will think, oh, I'm going to count three diagonals. No, you're actually measuring 1 centimeter, 2 centimeters, 3 centimeters, and that's what we did there. When we did that, we went 1, 2, 3. Okay. Now, we're still working with a grid, but this time they've changed the scale. They say that 1 on here, 1 of centimeter or 1 millimeter, whatever 1 is on here, is 1,000 in the real case. Okay, they give us points E, C and D, and they say work out the bearing of E from C. So if you're starting here at C, we want to find where E is, and E is over there. Okay, but the bearing always starts from north and it goes clockwise. So to do that, we have 90 degrees plus another 90 degree plus another 90 degrees. So to go around, we have 90 plus 90 plus 90, which will give you 270. Okay, and a bearing always has 3 digits. So that's okay, because in this case it came out with 3 digits. So the bearing of E from C is 270. Work out, for part C, work out the actual distance in meters of C from D. So we're going to have to check to see how many centimeters going from C to D, and it's 3 centimeters exactly. Okay, so 1 is the same as 1,000, but we have 3. So like before, we see what's happened on the left hand side, and you notice it's trebled times 3. So this time this side on the right hand side is trebled, and 3 times 1,000 is 3,000. Okay, but this here was centimeters. When I measured it, it was centimeters. So this one here will also be centimeters, which is fine, but they wanted the answer in meters. To change centimeters into meters, you must divide by 100. So if you divide 3,000 by 100, you'll end up with 30. Let's just check that to make sure I haven't made a mistake. 3,000 divided by 100 gives you 30. Excellent. And there's your answer. Brilliant. Okay, let's see how we're doing. We're on question 21. And question 21 looks 5 marks, and there's a little bit of working out to do. Jade works as a decorator. She's paid £22.80 for every hour she works. For the first 35 hours each week, she's paid 15% more for each hour she works, which is extra on top of the 35 hours. 1 week Jane was paid £981 with 54 pence. In total, how many hours did she work that week? So notice that we'll have to break it down a little bit and see how that total was made up. What you do first is really up to you, but what I'm going to do is I'm going to do the extra hours, because we know that 15% more. So I'm going to work out how much she's paid extra. 15% of £22.80. I'm just working out how much she would be paid when she did that. So 15 out of 100 multiplied by £22.80 comes out to £3.42. So she would get an extra £3.42. So instead of being paid £22.80 when she does it extra, she's paid another £3.42. So we have £3.42 plus £22.80, which comes out to £26.22. £26.22. Okay, that's what she is paid extra when she does. Okay, so now we will break it down. So we know that the first 35 hours she's paid that much. So the first 35 hours she's paid £22.80. So 35 times £22.80 comes out 798. And that's the normal pay, normal rate. But she was paid a total of £981.54. So we're going to take away the normal amount, the normal rate for 35 hours. So 981.54 take away 798 gives us an answer of £183 with 54 pence, which was at the extra rate. To find out how many hours she worked, we're going to have to divide that by the extra rate there. So we have 183, sorry about that, made a little mistake there, 183.54 divided by 26.22, and that will tell me how many hours she did extra. Divided by 26.22, and it comes out to 7 extra hours. So we know that she was working 35 hours at normal rate plus another 7 hours, which will give us 42. Yeah, there we are, 42. So in total she worked for 42 hours. 5 marks. So have a little think about the steps. You might have done them in a slightly different order, but you should still get 42 at the end. After that long question, we're back to a 1 mark question, and it says the cube of x is 125. Circle the value of x squared. So we're going to have to work backwards, because basically they're telling us that if you cube x, you get 125. So to find x, we're going to have to work backwards by cube rooting 125. Now, if you know your cube numbers, you'll know the answer already. That's 5. Otherwise, you're going to have to do your cube root. Okay, so cube root of 125 comes out to 5. So x is worth 5. So when we square x, 5 squared is 25. Yeah, because that there is 5 squared, which will come out to 25. Again, if you know your times tables, that's easy. Otherwise, you'll need to use your calculator. You then on to question 23, and question 23 says we have a sequence, and they've got a sequence here. And the sequence follows the rule, and the rule is after the first 2 terms, these are your terms, each term is the sum of the previous 2. So in other words, a plus 19 gives us b, 19 plus b gives us 45, b plus 45 gives us c. Work out the values of each of those. So you have to think, how do they work out? Well, the one bit I can spot is that 19 plus b would equal 45. So working backwards, b would be 45 take away 19. So 45 take away 19 comes out to 26. So b is 26. So down here I can write b equals 26. Okay. And you can check it because you can say 26 plus 10 is 36, 36 plus 9 is 45. Okay, now we know what b is. We can say that a plus 19 equals b, but we know that b is 26. So we can work backwards. So 26 take away 19. 26 take away 19 comes out to 7. So a is 7. I should have had here a equals 7. Okay. And now we're on to the last bit, which is b plus 45 equals c. But again, I made a mistake because, well, I haven't made a mistake. I just could have substituted because we know what b is. B is 26. So 26 plus 45 is c. Well, we can straight away do that. 26 plus 45 comes out to 71. So c equals 71. If you're not sure, you could always just check it. So we put 7 here. 7 plus 19 is 26. And indeed, we said that b was 26. And 19 plus 26, we already checked to make sure it was 45. And then the last one would be 26 plus 45 to see if it gives you 71. 26 plus 45 does indeed give 71. Excellent. Question 24 has an A part and a B part over there. Question 24 says here we have a triangle, and they're telling us to assume, imagine the angle PRQ going from P to R to Q is 90. So they're saying assume that that's a 90-degree angle. Work out the lengths of P to Q. So that's the one we were looking for there. Now the moment they said it's a 90-degree triangle, we know we're going to be using Pythagoras. And we're looking for the hypotenuse, the longest side, and so to do that we're going to have the sum of the squares of the other two sides. So 25 squared plus 11 squared, and then we're going to square root it, and that will give us our answer. We can do it all in one step using the calculator. Square root of 25 squared plus 11 squared gives an answer of square root of 746. So I'm just going to write that down to start with, just so you know what I'm talking about, and then we're going to write it down as decimal. And as decimal it's 27.31300, and it just goes on forever. But here they had no decimals, so I'm going to call it 27. Okay, it's approximately 27. It's approximately 27 centimeters. So what does part B say? Part B says the actual length of P to Q is less than your answer. So they're telling us it's less than 27. Okay, so this here is less. What does that tell us? What does it mean? What does it tell us about the angle PRQ? Well, if this is smaller, it means that the angle here is going to be smaller because these two lines have basically it's an acute angle. In other words, it's going to be smaller than 90. So we're looking for an answer that says it's smaller than 90. So let's see, it's 90, no, because that means there's been no change. There we are, it's smaller than 90. If it's more, it would be bigger, and you could be under the above. No, we definitely know what it is. Question 25 is an algebra question, and they're asking to make t the subject. In other words, at the moment it says here s equals, but when we come to do our answer, we'll have t equals. So to do that, what we need to do is do the steps. So we're going to start with s is equal to 7 lots of t plus 3. So what do? Well, we don't want that plus 3 there, so we're going to take 3 away from that side. So we have to take 3 away from that side. So to do that, we're going to end up here with s, make it look like more like an s, take away 3. And here the 3, take away 3 disappears to just leave us with 7t. So we're getting very close because now we have 7t. To get the t on its own, we're going to have to divide by 7 because it's a multiplication, which means we have to divide that side by 7. 7 divided by 7 gives us 1t, which is what we have. And we have on this side something that looks like this, an s. Try to make it look like an s. Take away 3 all over 7. And that's our answer. Okay. If you solve equations, you can also rearrange formulas. question 26 has a triangle. They're asking us to describe the single transformation that maps triangle ADE onto ABC. Notice it's got bigger. Now the four transformations are translation, moving, reflection, enlargement and rotation. Now the only one that applies here is it's going to be enlargement. However, notice that they said describe it fully and 3 marks. If I just write that, I'm only going to get 1 mark. So what happened? Well, it's got bigger, okay? So we're going to have to put a scale factor. Now how can we compare it? Well, here the height was 2 and the height of the new one is 2, 4, 6, 8. So what have you done to 2 to make it 8? Well, 2 lots of 4 is 8, so the scale factor is 4. So we now have 2 marks. Now where is the centre enlargement? Well, they've been quite nice because notice that this small triangle and large triangle kind of overlap. So the centre of enlargement is going to be A. How do we know that? Well, if I connect the corners, it crosses through A and it crosses through A. So here the centre of enlargement is A. Okay, and A is at 3, 9. And then they can't not give me the marks because I've got what it is, scale factor and the centre of enlargement, and I actually said where A is, just in case they want to argue with me. Question 27 is a 4-mark question. They tell us this ball has 3,000 centimeters cube of air in it, but more air is going to be pumped into the ball at a rate of every second 500 centimeters cube will be added to it. The ball is full of air when it becomes a sphere of radius 20 centimeters. Volume of the sphere, oh, they give us a formula here, 4/3 pi times radius cubed, where r is the radius. Does it take less than 1 minute to fill the ball? You must show your workings. Okay, so first of all, let's work out the volume of this ball. So we have 4/3 times pi times the radius. Now the radius was 20, and we need to cube it. To do that, I'm going to use the calculator button. Okay, so we're going to have 4/3, sorry, well, about calculator button, I mean the pi button on the calculator, times, there's my pi button, times 20 to the power of 3. And it comes out to that answer, but I'm going to change it to a decimal. I'm going to keep it on the calculator so I don't have to retype it in. It comes out to 33,510.32164. Okay, that's what the calculator says. And that would be in centimeters cubed. It's volume. Okay, but remember that's if it's that's how much it holds all together, but it already had some air in it. How much air did it have in? It already had 3,000 in there. So I'm going to take that answer, okay, the volume, and I'm going to take away 3,000 away from it. So I've kept the answer on my calculator, and I'm just going to take 3,000 away from it to get 30,510.32164. Okay, so that's how much more air needs to be added to the ball, and they tell us that every second 500 extra centimeter cube is added. So I'm going to divide the answer. Okay, so 30,510.32164 divided by 500 to see how many we'll get. So I have the answer still on my calculator, so I'm going to divide it by 500, and it comes out to 61.02 and a few more bits, but I don't need that now because it says basically how many minutes, and this is in seconds. Because how is it in seconds? Because up here it says every second. Okay, and the question is, does it take less than 1 minute to fill a ball? Well, if you look here, this is more than a minute, isn't it? Because 60 seconds is 1 minute. This is 61 seconds. So the answer is no. It takes more than a minute. Okay, nice. I just wrote it as a sentence. You could just say no and make it very clear. You could say something like 61. is bigger than 60 seconds, something like that, okay? Or you could say it takes 1 second longer. Anything that explains that you know that it takes longer. That was question 27, 4 marks. Question 28 is a bit of understanding working with negative numbers. It tells us that A is a negative number, B is a negative number, and we have to work out for each of these statements, is it always true, sometimes true, or never true. Okay, 4 marks because basically a mark for each one. So the first one says that if you add the 2 negative numbers together, you get a positive. Now, just as an example, -5 plus a -9, you see it's coming out as negative. Now, one example is not enough to prove it, but the point is, if you add negatives, you'll never get a positive because you always get more negatives coming out. Okay, you can notice there you had -5, -9, it's coming out to -14. Okay, so in this case, it can never be true. Okay, A minus B is positive. Well, try some things out. So you could have -5 take away -9, and you see it does come out as positive. But what would happen if you had something else? So let's see if we had something like -15 take away a -5, and that time it's a negative. So it shows that sometimes it's true and sometimes it's not. It just depends on which is bigger, the A or the B. Now for part the statement number 3, A squared, B squared, well, if you have a negative number and you square it, you're going to get positive, because negative times negative gives a positive, and this one's also going to be positive, and then you add them together, so that's always going to be true. It doesn't matter what, because they're negatives. Squaring a negative will give you a positive. And the last one is cubes, and for that one you kind of need to think a little bit what's happening when you cube a negative, so you might want to try it out. So bracket -2, close brackets, let's cube it, and the answer comes out to negative, because you do negative times negative times negative, which will give you a negative out. So in this case we end up with a cube giving a negative, and this cube giving a negative, and we're dividing them. So a negative number divided by a negative number actually gives you a positive, so it's always true. Question 29 is looking at 250 trains coming into a station. Every 50 trains, they record how many of them were, the number of trains, how many of them were on time. And here is a table. So after 50 trains, 32 of them were on time. After 100, 42 of them were on time. And here we have the relative frequency. And the way they're doing that is they're basically saying 32 divided by 50. Let's just check it. 32 divided by 50. And indeed we get the answer. So what we're going to do is we're going to complete this table, and then we're going to plot it. So to do that, we're going to do 108 divided by 150, which gives 0.72. The next one is 160 divided by 200, which comes out to 0.8. Now the only reason I've done that is all the others were 2 decimal places, so I thought let's keep it consistent. And this one here, we'll do this as a division. We'll end up here with 0.74. Now we need that so that we can plot it, because I've plotted the first 2, but we'll need to plot the next ones. So when it's 150, it's going to be at 0.72. Okay. Now notice that it's not jumping up in 0.1s, otherwise that would be, in 0.01s, because here we have 0, and if we were doing that, we'd end up here with basically being 0.05, 0.1, and so each of these boxes is actually going to be 0.02, so we're going to have to be a bit careful. And you can check that here, because notice for 0.4, yeah, for 0.4 they've used 2 boxes to represent that 4, and here for 4.2, so 0.42, they've used 1 box. Okay, so for this one we're going to need 1 box. So when we do that, we want the 7, and the 7 is going to be here between the 6 and 7, and 1 box. Okay, and then when we get to 8, well, that's a bit easier because that's exactly on the point there. And then for 7.4, we're going to be here 7, 2, 4, jumping up in twos. Okay, and so now we need to join them up with a ruler. Don't do it freehand because we want nice straight lines joining them up. Okay, there we are. So we've got our 3 marks, completing table and then plotting. It says here at the very end, write down the best estimate for the probability that train arriving at station is on time. Now, in any experiment, the more times you do something, the better. So here we had only 50, but here we have 250. So the best measure of the probability will be 0.74. Okay, so 0.74 will be the best answer for that one. Okay. Just making sure it's visible. And right, so now we're on to question 30. And question 30 is a circle, and they have points A, B, and C, and they tell us that the radii, in other words, from the center to A is radius, from the center to B is a radius. So in other words, this point here is exactly in the center, because otherwise they wouldn't be radii. Radii is just plural of radius. And they're asking us whether AC, going from A to C, is a diameter. Now, if it's a diameter, it would be a straight line. Okay, no kinks in it. And that would mean that the angles on this side would equal the angles on that side. Okay, you must show your workings. So I'm going to say if AC is a diameter, then 5x plus 30, because that's on one side of diameter, it would be 180, would be exactly identical to what's on the other side. And on the other side we have an x plus 2 lots of 2x plus 25. Okay, so if it is a diameter, then this side will come out exactly the same as that side. So let's work it out. So if that's true, here I have an x plus 2 lots of 2x will be 4x, and 2 lots of 25 will be 50. Okay, 4x plus x will be 5x. So I'm just kind of keeping that the same. Okay, 5x plus 50. Okay, but if you notice on this side we had 5x plus 30. Now the 5x's are the same, but the 30 and the 50 are not the same, so it's actually not true. If it were a diameter, that side would be equal to that side, and it's not equal, so since they're not equal, it is not a diameter. So it is not a diameter. Now the other way you could have done that is use this side to work out the value of x, and then substitute on that side and see. Now by that I meant make the side equal to 180, then find x, and then substitute on that side and see if it comes out to 180. Okay, there are other ways of doing it, but that was the fastest one that came to mind. So now we're on the last question, question 31. It says end of questions, and it says a straight line has a gradient of 5 and passes through the point 3, 11. Work out the equation of the line, and here they give us the equation of the line, so we just need to work that out. Okay, now remember that this here is your gradient, so the first thing we can do is we can just substitute it in. So we can have here that y is 5 lots of x plus c, but that won't get you the full marks because we've only found the gradient, we haven't found the intercept, and to do that we're going to have to substitute. And what you remember is that that there is your x and that there's your y, so we can substitute it in. So in other words, y is 11, and we have here 5 lots of x, and what is x worth? 3 plus c. So this calculation has to equal it to 11. So let's work it out. 5 times 3 is 15. 15 plus something is 11. Now the only way that's going to work is if actually it's a negative number, because we're taking away, aren't we? And how much we have to take away to get to 11? So 15, take away 1 would be 14, take away 2 would be 13, take away 3, 12, take away 4, 11. So we're going to have to take 4 away. Okay. So our actual equation of the line will look like this: y equals 5 lots of x take away 4. And that's it. That's the end of this paper. Hope that was useful. See you next time. Bye.